Pluto is not the world we spent a century believing it was. For nearly 100 years, we treated it as a footnote, a frozen speck drifting somewhere out at the ragged edge of the solar system, so small and so far away that we couldn't even agree on whether it had earned the word planet. In 2006, we stripped the title away by a show of hands. It became the only world in the entire history of astronomy to be discovered, named, celebrated, and then formally voted out of the category that made it famous. And for a long time, that felt like the end of its story. Then the James Webb Space Telescope fixed its enormous golden gaze on it. What came back through that mirror was not what anyone was prepared for, least of all from a world we had already filed away as dead. This is the story of what the most powerful telescope humanity has ever built, found waiting out there in the dark, and why what it saw should unsettle you, far more than almost anything else we have uncovered this century. The story starts in 1930, in a quiet observatory outside Flagstaff, Arizona, with a 24-year-old assistant who had never finished college. His name was Clyde Tombaugh, and his job was tedious beyond belief. Photograph the same patch of night sky twice, days apart, then flip between the plates looking for a single point of light that had moved. Most nights ended in nothing. Then, on one plate in February of that year, something blinked. A tiny dot had shifted position against a field of fixed stars. It shouldn't have been there. It was. That dot became Pluto, and for the better part of a century, it held the title of the 9th planet in the solar system. A distant curiosity, too far away and too small to study in any real detail. Astronomers guessed at its size. They guessed at its composition. They guessed at almost everything, because guessing was the only option available. Then, in 2006, a vote by the International Astronomical Union stripped Pluto of its planetary status entirely, reclassifying it as a dwarf planet. It remains the only world in recorded astronomical history to be discovered, celebrated, and then formally voted out of the category that made it famous. For most of the 20th century, that demotion felt final. Pluto was small, cold, and irrelevant. Case closed. Except the case was about to reopen in a way nobody expected. In July of 2015, after a 9.5-year journey across billions of miles of empty space, NASA's New Horizons spacecraft screamed past Pluto at more than 30,000 miles per hour. It had one shot. No orbit, no second pass, just a narrow window of a few precious minutes to capture everything it could before continuing on into the darkness of the Kuiper Belt forever. What it sent back rewired everything we thought we knew. A massive, pale, heart-shaped plane stretched across the surface, nearly 1,000 miles wide, smooth and strangely young-looking against the ancient, cratered terrain surrounding it. Mountains of solid water ice rose more than 10,000 feet into a thin, hazy sky, frozen so hard at those temperatures that it behaved less like ice and more like bedrock. Fields of nitrogen ice churned slowly in giant convection cells, resurfacing themselves from below in a process that suggested heat, motion, something active happening beneath a crust that was supposed to be dead. And wrapped around the entire planet, layer after layer of blue haze rose hundreds of miles into space, visible even backlit by the sun. Pluto did not look like a leftover. It looked like a world still in the process of becoming something. But New Horizons was a single glance. It captured what it captured, and then it kept flying, deeper into the Kuiper Belt, never to look back. Whatever it missed on that pass would remain a mystery. Scientists spent years arguing over the data, running models, filling notebooks with theories they had no way to test. What they needed wasn't a better photograph. They needed a way to read Pluto's chemistry from 91 million miles away, without ever leaving Earth's orbit. Enter the James Webb Space Telescope. Webb does not do flybys. It does not take postcards. What it does is far stranger and, in some ways, far more powerful. It reads light itself, breaking it apart into its component wavelengths to reveal the exact chemical fingerprint of whatever it's staring at. Point it at a pinprick of reflected sunlight 4 billion miles away, and it can tell you what molecules are present, how warm the surface is, and how the atmosphere is behaving. all without physically going anywhere. Starting in late 2022, Webb turned that golden mirror toward Pluto. And what came back wasn't a picture. It was a diagnosis, a list of molecules nobody expected in those proportions, a temperature pattern that broke the existing models, and a set of behaviors so unusual that researchers are still arguing about how to explain them. The first anomaly involved the haze. We already knew Pluto's thin atmosphere was wrapped in a delicate blue shroud of hydrocarbon particles, first spotted by New Horizons. What nobody had confirmed was what that haze was actually doing to the planet beneath it. Back in 2017, a planetary scientist at UC Santa Cruz named Shi Jiang floated an idea that sounded almost backwards. On Saturn's moon Titan, atmospheric haze traps heat, warming the world below it. Jiang argued Pluto's haze was doing the opposite, absorbing sunlight, then radiating that energy straight back out into space in the infrared, faster than the thin atmosphere could hold onto it. In effect, the haze wasn't a blanket. It was a radiator, bleeding heat away from a world that had almost none to spare. Years later, an international team led by researcher Tanguy Bertrand pointed Webb's mid-infrared instrument at Pluto and measured exactly that effect happening in real time. Pluto's atmosphere is being actively cooled by the very particles suspended within it. No other known atmosphere in the solar system behaves this way. Pluto isn't just cold because it's far from the sun. Pluto is running its own refrigeration system, and researchers still don't fully understand how far the consequences of that reach. The second discovery is quieter, but arguably stranger. Even the faint trickle of sunlight reaching Pluto is enough to break apart methane molecules high in its atmosphere. The fragments don't just disappear, they recombine into heavier compounds, ethane, acetylene, a whole cascade of increasingly complex hydrocarbons that grow heavier as they drift downward, eventually clumping into reddish-brown particles called tholins. New Horizons caught traces of this chemistry in 2015. Webb has now mapped it with a precision no instrument has ever achieved. And here is the part that should stop you. Tholins belong to the same broad family of organic molecules some scientists believe once rained down onto early Earth, potentially contributing raw material for the chemistry that eventually became life. On Pluto, that same process has been running, uninterrupted, for roughly 4 billion years. A slow, continuous snowfall of biological building blocks drifting onto a surface too frozen for any of it to ever ignite into something living. It is the chemistry of life, playing out in exquisite detail on a world that will never be warm enough to use it. To understand how alien that cold really is, consider the numbers. Sunlight at Pluto's distance is roughly 1,000 times fainter than sunlight on Earth. High noon there looks like heavy twilight here. Surface temperatures hover between roughly -387 and -369 degrees Fahrenheit, more than 250 degrees colder than the coldest temperature ever recorded on Earth. At those temperatures, nitrogen, the gas that fills most of the air you're breathing right now, freezes solid. Methane becomes something closer to a glacier. The atmosphere we walk through every day is, on Pluto, simply part of the landscape. The third finding is the one that tends to unsettle people the most. Pluto has been leaking, constantly, for billions of years. Methane and other light molecules drift up through its thin atmosphere, slip past its weak gravity, and escape into space. Scientists already suspected this much. What they didn't know for certain was where all of that escaped material was going. It wasn't disappearing. Something was catching it. Pluto's largest companion, Charon, is a battered ice moon roughly 750 miles across, locked in a tight gravitational partnership with the dwarf planet. Charon has no atmosphere of its own, and most of its surface is unremarkable water ice, ancient and heavily cratered, except at its poles, which are stained a deep, unmistakable reddish-brown, darker than anything else on the moon's face. For decades, researchers suspected a connection to Pluto, but lacked the tools to prove it. Webb provided the proof. In a series of papers published in 2024 and 2025, the same research team that confirmed the haze cooling effect demonstrated that Charon's colored poles are built from material stolen directly from Pluto's atmosphere. Escaping methane molecules drift across roughly 12,000 miles of open space, get captured by Charon's gravity, freeze onto its polar surface, and are then broken apart by sunlight and cosmic radiation into the same heavy organic compounds that color Pluto itself. Two worlds, locked in a slow exchange of atmosphere and color that has been quietly running since before either world had a name. And Charon has one more secret. In October of 2024, a team led by researcher Sylvia Protopapa at the Southwest Research Institute confirmed the presence of both carbon dioxide, the gas leaving your lungs right now, and hydrogen peroxide, the compound you'd use to disinfect a wound, frozen onto Charon's surface. Both produce the same way, radiation tearing apart water ice and reassembling the fragments into something new. Picture standing on Pluto's surface for a moment, because the details are almost impossible to imagine otherwise. The sun would still be visible, but only as an intensely bright point of light, smaller than a pinhead held at arm's length, throwing no warmth and no glare. You could stare directly at it without discomfort. The sky around it would sit in a permanent greyish-blue gloom, thick with haze, neither day nor true night, just an endless, unchanging dimness. The ground beneath your boots would not behave the way ice does on Earth. At nearly 400 degrees below zero, water ice stops being slippery and starts behaving like solid rock, hard enough to ring like metal if struck. The atmosphere, roughly 100,000 times thinner than Earth's, would offer nothing to breathe. But that wouldn't be the first danger. The cold would reach you before the vacuum did, freezing exposed skin almost instantly. And above you, unmoving, hanging fixed in the same spot in the sky forever, Charon would watch. The two worlds are matched closely enough in size that they don't orbit each other the way Earth orbits its moon. They orbit a shared point in empty space between them, locked so tightly that each always shows the same face to the other, a silent standoff stretching across 12,000 miles, running for billions of years. The surface holds its own mysteries, independent of the sky. In a region called Tartarus Dorsa, New Horizons photographed something no spacecraft had ever documented anywhere in the solar system. Rows of towering ice blades, some reaching over 1,500 feet tall, made of frozen methane and arranged in long, parallel ridges. Similar but far smaller formations exist on Earth, in high-altitude deserts, where they're called penitentes, and rarely grow taller than a person. A 2025 analysis of the New Horizons data suggests these frozen blades may wrap around as much as 60% of Pluto's equator, an entire ring of jagged ice circling the dwarf planet. Elsewhere, a massive dark region, roughly the size of Alaska, drapes across the equator, colored a deep reddish black. This is where the tholins, the organic particles raining down from that atmospheric chemistry, have piled up thickest over billions of years on the oldest and most exposed terrain on the planet. It is, in a very real sense, the part of Pluto that has spent the longest amount of time absorbing its own sky. South of the Great Pale Heart, two enormous, isolated peaks rise out of the surrounding landscape, and nobody can fully explain them. One stands roughly 13,000 feet tall. The other may reach close to 20,000 feet, with a base wide enough to rival the largest volcano on Earth. Both mountains have deep depressions at their summits, ringed by fractures, with lumpy, uneven flanks that closely resemble cooled lava flows here on Earth. Except, there's no magma on Pluto. If these are what they appear to be, they're cryovolcanoes, structures that once erupted not molten rock, but a thick slurry of water, ammonia, and methane forced up from somewhere deep beneath the crust. Researchers are still divided on exactly how these features formed, whether from a handful of massive eruptions or many small events over a longer period. But either interpretation points to the same unsettling conclusion. Something, at some point in Pluto's relatively recent geological history, was warm enough beneath that frozen shell to force liquid material to the surface. A world we assumed had gone cold and still a long time ago may have been geologically active far more recently than anyone expected. That internal heat leads to the most controversial idea surrounding Pluto today: the possibility of a hidden ocean buried roughly 100 miles beneath the surface, kept liquid by the slow decay of radioactive elements inside Pluto's rocky core. The evidence isn't a photograph. It's a pattern. Cracks and ridges across the surface line up in ways that fit a subsurface layer of liquid water shifting beneath the crust. The pale heart-shaped plane itself sits over what appears to be a positive gravity anomaly, a spot where something denser than the surrounding ice may be concentrated underneath. If that ocean is real, it has likely existed for billions of years, sealed away from sunlight, from radiation, from everything happening on the surface above it, fed only by hydrocarbons occasionally seeping down through cracks in the ice. Dark, under enormous pressure, and utterly isolated. It would be one of the strangest candidate environments in the solar system, for the basic conditions life requires, existing without any direct connection to a star at all. We have no way to confirm it. There is no funded mission to send a probe back to Pluto, no lander, no orbiter currently on the books. The journey alone takes the better part of a decade, and outer solar system exploration has never been a budget priority. For now, Webb remains our only working tool, checking in every few months whenever Pluto swings back into view, adding another data point each time, refining the models a little further, and almost always making the picture stranger than it was before. Here's the detail that tends to stay with people longest. Pluto is not unique in its location. It sits inside the Kuiper Belt, a vast ring of icy debris beyond Neptune, home to hundreds of thousands of objects wider than 60 miles and an estimated trillion comets. A handful, like Eris and Makemake, come close to Pluto's size. Beyond the Kuiper Belt entirely lies the Oort cloud, thought to hold another trillion or so icy bodies, stretching out roughly a quarter of the way toward the nearest star. If Pluto is running this kind of chemistry, cooling its own sky, bleeding its atmosphere onto a companion moon, possibly hiding an ocean beneath a shell of solid ice, there is no obvious reason to think it's the only one. It's simply the one close enough and bright enough for our instruments to study in detail. Everything else out there, the countless smaller bodies scattered across a region of space hundreds of times larger than the asteroid belt, remains almost entirely unobserved. When New Horizons made its historic flyby back in 2015, the mission's lead scientist said the images would stay with him for the rest of his life. Webb has taken that same sense of wonder and made it permanent, arriving in new pieces every few months, each one stranger than the last. Pluto was never the dead end of the solar system. It was the beginning of a question we're only just learning how to ask. Out past the orbit of Neptune, in the dark and the cold, there are trillions of worlds we haven't even looked at yet. And if one frozen dwarf planet was hiding this much, it's worth wondering what the rest of them are hiding too. Thanks for watching, and I'll see you in the next one.